Okay, it's doing really well. So those are the start of the operations that we can look at. I also want to look at, in this lesson, the dot product and what that actually helps us find. So with the dot product, there is a formula for that, and it is on your formula sheet. It looks something like this. So let's say we want to find the dot product of A and B, right? And the formula for that is written like this: x1, x2 plus y1, y2. Now there is a bit of a definition that they give you on the formula sheet in terms of what x1, x2 and y1, y2 actually are, but essentially what you're doing is you're taking the respective horizontal components, multiplying them, and you're adding that with the respective vertical components when they're multiplied together, right? So if we look at our A and B vectors over here, our respective horizontal, low battery, our respective horizontal components are, for A and B, they're 3 and -2. So we're doing 3 multiplied by -2. So 3 times -2, and I'm adding that with the vertical components multiplied together. So -5 times 1, right? And what's that going to give me? It's going to give me -6 minus 5, so -11 there, okay? So that's how we can use the formulaic approach to the dot product. But I guess it kind of begs the question, what does the dot product actually mean, and what does it kind of do? Well, here's another visual representation, because you know me, I'm a very visual person. And this is meant to give us a little bit of an insight into what the dot product actually is. So right now, I have 2 vectors here, and you can see that they're at right angles, they're perpendicular, and the dot product is actually 0. So this is actually a property and a feature you can use to prove if 2 vectors are perpendicular, if the dot product is 0. This value here is 0, right? But as you start to change the angle, right, you can see that it's an acute angle right now, and it's a positive value when I calculate the dot product in the green there. But once I start changing it now to obtuse, what happens? Well, it goes to a negative dot product. And so it's very key idea that the dot product is affected by the angle which is created, because the dot product is finding this kind of directional growth that's applied to our vectors over here, okay? So that's a very key idea, and actually is going to help us find the answer to our next problem, because the next problem is saying find the angle between the 2 vectors. So part 5, find the angle between A and B. Now you can actually do this visually, and I just bring that up again for you guys. Oh, have I covered it a bit too much? Hopefully you can still see. So these are vectors A and B. And if we wanted to find the angle here, like think about what you're expecting. Like, well, hang on, there's one angle over here, and there's actually another angle over here. Now the dot product is actually going to help us find the non-reflex angle, and that's kind of its definition. So don't worry about that one over there, okay? So you could do this in a few different ways, right? You can obviously use trigonometry to find these respective angles and do it that way. But if you have the dot product and its definition allows you to do that, there's a reason why you can't do that as well, okay? But just be aware, if you are going to use your trigonometric rules to find these thetas, then you have to make sure you find the non-reflex angle for the angle between the vectors there, okay? So let's go back. And so the angle between A and B, I said that the dot product is a key idea to that. And that's because its definition, right, it is defined as this formula over here, but there's another definition, and you already saw how the direction of the vector is very key to that, right? And this is its other definition. The dot product can also be calculated by taking the magnitudes respective of A and B and multiplying by that by cos theta, where theta is the angle between them, okay? So remember, these are the magnitudes, and theta is the angle between the 2 vectors. So you can see now how we can approach this. We already have the dot product, that's a -11. The respective magnitudes we can find, right? Because remember, that's just Pythagoras' theorem. So the magnitude of A is just going to be the square root of 3 squared plus -5 squared. And so that's going to give me, it's 36, quite a nice number. Sorry, no, maths, 6. The square root of 36 is 6. And then the magnitude of B is just going to be the square root of -2 squared plus 1 squared, well, that's just the square root of 5, okay? So we can substitute these values in now. So that's the 6 square root 5 cos theta. And because I'm trying to find theta, we can divide both sides by that. All right, and I'm trying to find theta here, so we'll take the inverse of both sides. And what kind of angle are we expecting? Well, hopefully it's going to be like an obtuse angle. Split. Yeah, and we do get, so it's 145 degrees and 4 minutes. Okay, so just to show you again really clearly, that angle that we just found, this guy over here is 145 degrees, 4 minutes. It does kind of check out like that. And remember, it's actually this formula here that you're using when you apply cos theta here is looking for the non-reflex angle. If for some reason you had to find that, you could just take it away from 360. But that's how we can use the dot product to find the angle between vectors as well. Right? So that's just a brief overview of the basic kind of questions you can ask. You can look at the notations and all the different additional subtractions. We'll also do some more complex operations like magnitude, direction, and the dot product. Projections we'll have a look at next lesson. Okay.